guys, welcome to the tutorial. Your instruction for today is Orchidee. We're going to be building our job listings backend in Node.js, specifically using the Nest.js framework. This tutorial will be of greater help if you have some experience writing Node.js application and maybe you've written a few endpoints in express.js, because all of the concepts and features we're going to be talking about here are predicated from the knowledge of Node.js and maybe Express.js as well. Nest.js, as opposed to Express.js, is more of a fully fledged framework where a lot of the folder structure is opinionated. It has its own Nest.js way of doing things. It's kind of more like what Angular is to React. In React, you have the freedom of structuring your project how you want, but when you step up things to Angular, you'll find that there is the Angular way to do a certain way of things. This comes up with a few positives, meaning folder structure or code organization, and basically the framework makes it difficult for you or for the team, if you're working on a large scale project, to write bad code, so to speak. Now, if you have not used Nest.js framework before, I would recommend maybe you take a look at a crash course. This project is going to be in depth as to how to build backend applications using Nest.js. We're going to be using Postgres on the backend, and we're going to be using typeorm for our object relationship mapper. You could use SQLize as well, but in this project, you're going to be using typeorm. It has a very seamless integration with Nest.js. So without further ado, let's step into setting up the project, walk you through the basics of how Nest.js works, and then we're going to get going. See you soon. Now let's take a look at Nest.js, open the documentation, and then try to set the project up. As you can see, you're going to have to install, you have a lot of what the philosophy and what Nest.js is all about right here. You can take time and read it after. And then you're going to have to install it like so. I already have it installed on my machine, so I don't have to run this again. So once you have the project installed, then we can get started. So let's go ahead and open up the terminal. Switching to a terminal, making sure I'm on my desktop. Okay, and then run nest new. Then we're gonna name it patch and posty, so that we can bootstrap our application. For this project, I'm gonna use Yarn, but you can feel free to use any other package manager you want. I'm gonna give it a moment. That you have your project initialized, let's cd into patch and posty and then look at the folder structure. Then run Visual VS Code in it. All right, let's bring up our terminal by pressing Control and backtick, and then let's just look at the project structure. All right, so you have your source folder, which is where everything will be. And then you have your test folder, you have your package.json file, and then the Nest CLI, and a few more files right here. All right, so let me take you through the basics of Nest.js according to this default folder structure. In Nest.js, basically, we have controllers, we have modules and services. A controller is basically your route handler, where you write your endpoints, okay? And then the app module is basically where everything that has to do with dependencies and other services that your app is going to be interacting with are initialized. Say for instance here you have another module, we'll call it authentication, that you want to import into the app module. You use the module file to do that and handle that for you. And then the service file is where we write the actual application logic. This is where you're going to be making your database calls. This is where you're going to be doing all the magic, if you will. Okay, we're going to clean it all up and structure it better to bring some more organization to it, and then get to write code. Actually, I just wanted to explain to you how all that works. We also have the main.ts file. This is where we run our application and bootstrap it. Basically, this is the file that cranks up the Nest application and brings it up to life. Here you'll write your app prefixes. Say you want your endpoints to be prefixed by API version 1. You want to include your security your security JavaScript modules. They're all initialized here at runtime so that they're all available throughout the app. This is going to be many more lines than just two when we get to start. But yeah, anyways. So we're going to be interacting with Postgres. Now, I prefer to Dockerize our Postgres databases. Our endpoints are going to be cached as well. We're going to be using Redis for caching. Without further ado, without boring you with too many details, in the next video, we're going to be building our Docker Compose file so that we can have our databases and our cache layer initialized without having to spend too much time installing them locally on our local machine. If you do not have Docker, I highly suggest that you look at Docker Hub on how to install Docker. Once you install Docker, all you have to do is basically copy and paste the Docker Compose file that I'll be building for you guys, and then we'll get started. Thank you very much. See you in the next one. All right, guys. Now let's create our Docker Compose file. Docker-compose.yaml. I'm just gonna paste it in and then explain to you guys what's going on. Basically, we're establishing or creating two services, called PostgresDB and RedisDB. RedisDB is going to be our caching layer if we ever need to cache anything, and PostgresDB is going to be our database. Okay. Now we already are using the Postgres 14 Docker image. This is our environment variables for that image, and the same applies to Redis. So let us initialize our Docker file, and then and basically create our Postgres and Redis. Compose up /d. Okay, it's already running. We're gonna get rid of that and start with cleaning up our source folder. I want to organize our code such that our tests are going to get written outside our code. Let's start with getting rid of the app controller.test file. Okay, we're going to delete our app controller as well. Okay, and then you can see that it's already throwing errors. Get rid of those as well. Okay, and then we'll cd into source folder, and then right here I'll create a modules folder, and then cd into modules folder, and then nest generate module, call it users. Okay, it should be generated right here. Okay, and then cd into users. We'll generate a controller, nest generate controller. Users controller. Oops. I think we just create them manually without using the CLI, lest we complicate things more than it should be. Modules, users, we're going to create users.controller.type.ts, and then users.service.ts. Okay, we now have it all here. Now let's go ahead and discuss how this is going to work. Now, we're gonna be creating a listings app. The listings application is gonna need jobs. You're gonna need users who create and apply to those jobs, and you're gonna have also job applications. Now, before we get into all that, I just want to set up the basic tables that our application is gonna need, starting from the user table. Okay. Our users table is gonna be consisting of the full name, the status of the user, and maybe a few more columns. We're gonna develop it all as we go along. But before we get there, let's cd into the source folder, the root file, and then run yarn run start dev. This is where you're gonna find the commands to start your application, your Nest.js application in various modes. Let's try to start it. Oops, we already have an error. Command click, so we can take a look at what's going on here. Oh, it's not finding our user's controller. That's fine. We're going to be adding those later. Okay, our application is successfully started, and it's running on port 3000. Now before we add any more modules to it, let's try to connect our application to Postgres. Okay. Before we do that, we're going to need to install a few dependencies from Postgres. We'll need nestjs type-orm. We'll need type-orm itself and pg as well, which is the Postgres driver. Okay, now that we have our Postgres dependencies installed, let's try to create our environment variables. .env. I'm just gonna paste them in here. Let's take a look, and then let's go to our app module folder. And then let's try to bring in our type-orm module so that we can try to connect to the database. All this is in the Nest.js. All this is in the Nest.js documentation, guys. You can take a look at it. We're just trying to set up the application real quick. Okay. Gonna name this later. Port. Can put this on later. The host. We'll fill this in later. User. Okay. Password. And I think that's it for now, just so that we can be able to connect to our database. Now we need one more dependency. We're going to be adding .env, which is a Node.js package to let us deal, or to help us deal with environment variables. Okay, to load them in our application. All right. Let's just bring it in right here. Get rid of this linting error. All right. Oops. Sorry about that. Now let's bring in, it's going to come from process.env dot database name. I think that's what we named it. I think it's database name. our port. Now, because in our environment variable, our port is brought in as a string, we're gonna have to parse it as an integer, because as you can see, this expects a number. We're gonna have to go parse int process.env.database port. Okay, and then our host is going to come from process.env.database host. I think that's what we named it. Let's take a look. Yep. And password is going to come from process.env.database password. Okay. Let's start our application. Oops, sorry, that's the wrong. You press arrow key to have access to the most recently used. Oops, we forgot to provide the kind of database we're interacting with, or the driver, which is Postgres in this case for us. Oops, I think we might have forgotten something. Let's take a look at our Docker Compose file. I think maybe the problem could be that we omitted the username of our database, and Postgres is attempting to connect using the default user. Okay, let's take a look at what we said was the default username. Database username is Postgres. Take a look. Okay, database username. Let's yarn run start dev again to see if we can connect to a database successfully. Got it. We're successfully connected. We don't need to reference .env anywhere. We just require it. And yeah, 100%. We're ready to move and start setting up our project structure. Now, starting with the users module, let's start with creating entities. We'll have an entities entity folder, and then user.entity.typescript. Okay, now you might be wondering, how does Nest.js or how does TypeORM know how to load entities in our database? How does TypeORM know which folder or what's the path to our entities? Entities are basically the way we lay out our tables programmatically. That is, we're not going to be writing raw SQL queries or anything like that. So we're gonna have to get back into our app module, all right, and then add another field right here to point TypeORM, where it's gonna be finding our entities. Now, as you can see right here, every time we rerun our application, Nest.js compiles our TypeScript into JavaScript and then puts it into the dist folder, right? The dist folder is where our entities are going to be located, at least the compiled ones. And those are the ones that TypeORM uses to populate our database. Okay, so it's going to be in dist. And then form of a regular expression right here in any folder, where each file in any folder that ends in .entity.js. Okay, we don't have any entities as of yet, but once we start writing them, we're gonna be finding our tables created and everything set up. Okay, let's go back to user entity. It's actually entities. All right, and then let's create our first table. Now, before we get there, each table has obviously a unique identifier. You're gonna want to have your created at column and the deleted at column, and that's just going to be shared across all the tables within our backend. So it is worthwhile creating a base entity, which all other entities are going to be extending from. You'll see that in motion a little bit. So let's create our commons folder. which is basically going to be everything that that's shared across all the applications. All right, within commons, we'll create another entities folder, which is basically uh, the the shared entities across all the application. All right, so it's going to be common.entity.ts, and then we'll export our class. We'll name it base entity. We'll annotate it with entity from type ORM. Press command dot to import it. All right. So our base entity is going to be just gonna contain two fields, primary key column ID string, and then our updated at column. Sorry about that. It's going to be of type, if I can type, it's going to be a date. It's going to be a timestamp rather. This is how you do it in type ORM. Did it at. It's going to be optional. And then at created column, it's also going to be of type timestamp created at. It's also going to be optional. Okay, we're going to have to import all these from type ORM to fix our missing imports. And then heading back to our user entity, before we even create it, we need to think of, what is our user going to look like, okay? Our user will have things like a username, they'll have a password, they'll have a status, and so forth. So let's go ahead and design our user. So okay, we'll start with annotating the user entity with the entity annotation. Okay, and then export class user, and then it'll extend the base entity we've created. However, it's going to be imported from common entities instead of type ORM, and then we'll start creating our columns, right? Creating columns in type ORM is as simple as annotating a variable name with column. Okay, I also can use validation right here, which is gonna be the next step. But let's just create our columns first. Okay, so let's create a column for full name. It's gonna be a string. Another column for say maybe this user is gonna need particular roles. Okay. For now, we'll just assign it to an array of strings. What else? The user will have maybe a status. So column string for now. Before getting to particular user types and how to deal with them in Postgres and type ORM, a user will also have maybe an email. Okay, let's stop it here for now, and then we'll grow this table later on. So now let's determine the types so that we can have database level validation, and maybe create things like indices. We don't want to be allowing full search where in a data set that's not indexed. Okay, so let's start with here. The type here is going to be text. Okay, and then we'll leave it at that. And also nullable is going to be false, just so we enforce that each user must have a full name before we submit them. Here, nullable false as well. Status, we'll leave status for later for now. And then for email, also nullable is going to be false, okay? And then the type is just going to be text as well. Okay. Now okay, we're gonna handle that later. Now our status ideally should be something of an enum and a particular set statuses. So to handle that, we're gonna create our enums. Okay, I'll go to common, within the common folder, create another folder, call it enum. Okay, and then common.enum.typescript. All right, I'm just paste it in here for better visibility. And then, so as you can see, our users can be either active or disabled. We can change and run around this as we please, but for now, let's just, for the sake of moving faster and quicker, let's just move ahead. I'll come back to our user entity right here, and we're going to change the type of the status column to enum, okay? Type, it's going to be enum, and then give it a default value to user status enum dot active, okay? Nullable obviously is false because by the time we create a user, they'll be immediately created as status active. All right. Okay. Oh, we forgot to give them password. A column. Type is text. The nullable for passwords is going to be true. Sorry about that. Because once you create a user, you don't wanna assign them a password right then and there. You want them to create and put in their password later. Okay, so let's restart our application. Run start dev. Oops, we have a problem in roles. Oops. Okay, so let's take a look. So type is going to be JSONB, so we can fit our roles in here. Okay, let's take a look at what it's saying. Oops, okay, I think we have a problem with our enum and how it's being handled. Let's take a look at it. Oops, we didn't provide what the enum actually is. So it's gonna be enum, user status, and that's it. Let's run our application again. Run start dev. Okay, so now to ensure that our user module is loading our enums, we're gonna have to bring in, is loading our table, sorry, you're gonna have to bring in the user module right here. After we've imported in type.rm, user module. Okay, it's brought in, it's loaded. Okay, now let's take a look at our table or database. Let's open table plus. Let's just opening table plus right here. It's already open for me. I had it on my doc. If you don't need to use table plus. It's just that it's my preferred lightweight database client. You can use any other one you want. If it's Postgres, you can use pgadmin for this task. It's not really necessary to use table plus. Let's create a new connection. Let's call it patch and posty. It's localhost. Username is Postgres. Let's test the connection to see if it works. Oops, there is a typo. Again, great. Let's connect. And our tables are not created yet. So let's go back to our code and take a look at what's going on. Okay, let's open our users module. Okay, just import type.rem module .for feature, and this is where we pass in our user entity for it to load it. Okay, got that. Let's take a look. Refresh all our functions. Oops, doesn't seem like our users module is there yet. I think that we might have forgotten to synchronize our entities with the database. Now, we don't want to do this in production, but for the purposes of this video, this will do just fine. Now we go to, yep, we find them there now. All right. Okay. Now, I think we have pretty much the largest swath of our application set up. Oops, let's just move this up into users. Got it. Modules, users. No, sorry about that. So we got the project is set up. Now we just write a few controllers for our users so we can try to write controller export class user controller. Now, as I said, the user controller serves as the endpoints or the route handler. Okay, so we're gonna do user. Okay, now we're gonna create our first endpoint, which is to create a user. And second endpoint is gonna be get. It's going to be get user, maybe by ID as well. Get user. All right, now let's start with create user. For us to create users, we're gonna be structuring it. The structure is gonna be such that our route handlers are gonna be calling the service layer of our application, which is where the logic is. Let's get there. So let's just first save all this. Bring in all our imports. Great. What's the problem here? We don't need that. Sorry about that. Okay, let's get into a service layer and start writing our application logic to create and fetch users in the database. Okay, so our class is going to be injectable for us to use dependency injection as user service. All right, and in our constructor, we'll inject the user's repository. What this is type.rem's way to bring all the database function in this class, so we can use things like find one by ID, delete on the database layer. So we're using the repository pattern here, and it's simplified by type.rem by injecting in the inject repository, pass it the user entity, bring that in, and then just private read only user repository, which is going to be type repository of user, and that's it. Just also load our injectable from Nest.js common, and then let's create our first function, first method. Say save user to database. We take in a create user request DTO. We'll set this one later. All right. So let's go ahead and create our DTOs. We get into our users folder. New folder, DTOs. Create, and then user.dto.ts. Export class, create user request DTO. Okay, this is where we define all the required fields for our DTOs to happen. This also helps in validating our inputs and making sure they're sanitized. So let's close this up and install a dependency called class validator. This is much more difficult to do in frameworks like Express. You literally have to write your own validators, even if you actually have class transformers. Let's install the dependency. Oops. Yarn add. We forgot something. There you go. Now we can start defining what's required for anybody to create a user. So I'm gonna need so the full name of the user is gonna be a string. Their email is gonna be a string. The password, not for now. For the purpose of this stage in the video, we just want to be able to validate that our routes are working. What else? Let's just create full name and email, and that's it. So let's add validation. So the full name has to be a string. Is string, I think that's the name of the annotation for us to be able to validate that. So let's just bring it in. Oops. I'm not sure we installed a validator. Okay, let's try to import it. Import is string from class transformer. Okay, it's also, other than being a string, it's also required, so it's not empty. We also import is not empty from oops, I think we imported the wrong. Oh, sorry about that, guys. Let's just re-import sudo and add class validator instead of class transformer. Get rid of this. Command point, update our imports. Same applies to is not empty. Okay, is not empty, is string. So this will ensure that the full name is always part of the body that we send to the endpoint of creating a user, and it's also got to be a string. You're not gonna put a number for it to validate, which we are gonna see in a minute. We can also validate email has to be a string. It also has to be is email. Okay, let's just do that for now. Start our application. Oops, injectable. Great. Just import this. Awesome. Now let's write the logic. So for now, we're gonna do, let's just destructure this from create user DTO, const created user is gonna equal to await this dot user repository dot save. All right, now let's from here we'll get the full name and the email of the user. So let's take a look at our user entity. So it's a full names, email, and that's about it. Oops, we have an error somewhere. All right, now let's just return our created user just so that we can have it as in a body. Okay, now let's try to test this endpoint using Postman or your other favorite HTTP client. Let me open Postman right here. We got Postman right here. Okay, sorry about this. Let's just clean up all this. Okay, let's just open up the Postman, bring it up here. There you have it. Okay, let's test our new endpoint, which is going to be a post request to localhost, sorry, HTTP, localhost port 3000 / user. We go to the body, row JSON, full names, John Doe, email, say Jane Doe, sorry, John at doe.com. We send the request. Oops, we might have forgotten to correct our routes right here. Let's go to controller. Oh, sorry about this, guys. We forgot to register our controller. So constructor, we bring in private read only. Sorry about that. User service. Not like that. User service, which is gonna be type user service. We bring it in. Okay. And then within our user modules, our controller is going to be user controller. Providers, we're going to use user service as our provider. Okay, our controller, as you can see, has loaded all this, the /user and /user ID routes. So now we can use them. Here we just return this the user service dot create save user to database, and then let's define our body like so. Create user request, which will be of type create user request DTO, and then we just pass it in. We save, we go back to Postman, we send our request. We have an error. Let's take a look at it. Oops, okay, we forgot to associate or to provide roles for a user. Let's correct that and send the request again. Okay, we'll have to add roles. Okay, and then in our, we have to create to make a few changes. Take a look at our service. Let's take a look at our entity right here. Okay, back to our service layer. Okay, we're gonna have to roll and then add it here as well. So for roles, it's gonna have to be our role. Okay. All right, let's go back to Postman, add a role for John Doe. And his role is just, for now, it's just gonna be default. Okay, restart our application. Okay, send the request. Okay, so we already have John Doe created. We can go to the database and check it out. Let's refresh. Take a look at user. We already have John Doe created in the database. Okay, great. Let's work on getting John Doe out of the database before we move on to serious things. You know, this is basically merely setting the project up. We'll have to set it all up. We're just going to be moving on to starting with authentication and rewriting our users table so that it reflects what a real world project looks like. So let's go into our user controller. We already got a getter ID. This is how we bring in parameters, request parameters in Nest.js. What parameter is called ID? We'll name it ID. It's going to be a string. Okay. And we're going to write the actual logic. It's going to call async fetch user by ID. Return based on user repository. Find one where ID. Sorry, where ID. Okay. Let's go to our controller. User service dot fetch user by ID. Oops. All right. Now let's take a look at the UUID we got right here. Open up Postman, create a new request. It's going to be a get request on HTTP. localhost/user/ID. We'll send the request. We get John Doe. Cool. All right, guys. Thank you very much for watching. See you guys in the next one.